folks are coming in. We'll give it like a minute. Folks are coming in. We'll just give it a minute, and then we'll get started. All right, I think that's good. We got moving towards 100 folks. And if just happy Tuesday, everybody. Just real quick show of hands. If you could use the raise hand to let me know you can hear me, that'd be great. And then we'll officially get started. All right, we got some hand raising. Fantastic. My name is Jon Hume. I'm the VP of Global Sales here at SoapBox. I just want to say thanks for joining me and my colleagues today to talk about how voice tech supports teachers and students and all stakeholders in the learning journey. It powers screening, practice, intervention, and assessment for K-12 literacy and language learning tools. For those of you who don't know me yet, you could say I'm a veteran of the EdTech industry, having worked for a variety of tech companies for almost 2 decades. Can't believe I'm saying that out loud. But my main focus, the main focus of my career has been in EdTech and senior business development roles. I have a deep knowledge of our industry and of the opportunities and challenges that EdTech companies face as they're delivering new technologies to the market, whether they're focused on teachers, students, parents, or the classroom. I officially joined SoapBox in 2020, but my relationship with the company goes back many years, during which time I watched SoapBox develop their technology and become the benchmark for accuracy and privacy for voice technology in education. And as of 2021, SoapBox has 2 core market offerings. So SoapBox Educate, which is the set of solutions and features we'll be focusing on today, and SoapBox Play, which are solutions that overlap in many ways, but that have been developed to fulfill the needs of our toy and entertainment clients. Think of things like voice activity detection or VAD, voice search, wake word dialogue, and more. I am delighted to be with you today and to host this session with my colleagues, Dr. Patricia Scanlon and Dr. Amelia Kelly. I am going to read their quick bios as I am inspired every day to work with these 2 amazing people. So to start off, Trish is the founder and executive chair of SoapBox Labs. She is an engineer with a PhD in speech recognition. She has over 20 years experience working in the area, including at Bell Labs and IBM. Trish is an acclaimed TEDx speaker and was named to Ford's top 50 women in tech globally. Amelia is the VP of Speech Technology at SoapBox Labs. She holds a PhD in linguistics and speech technology and is an artificial intelligence engineer and scientist specializing in automatic speech recognition, or ASR, for children's voices. Amelia is a Fulbright Tech Impact Scholar for 2020 and 2021, and through a role at SoapBox Labs, is currently collaborating with the Colorado University Boulder's Institute of Cognitive Science. Both are mothers of young kids and have no shortage of firsthand experience of the challenges and opportunities for using all kinds of technology to enhance the learning experience for kids. And before I hand it over to Trish to get us started, just a quick review of the plan and some housekeeping. The agenda. So for the next 60 minutes, Trish will kick us off with a talk on how and why speech recognition can be a powerful tool in the classroom. She'll then hand it over to Amelia, who will walk us through a demo of the technology and how it works, and which will lead us to the Q&A, which is what we will end on. So a couple of housekeeping. We have a lot of folks on here, so everyone has been muted automatically. Please post any and all your questions in the Q&A tab at the bottom rather than in the chat. Today, again, we will not be using the chat, but the Q&A. We love questions, so during both Trish and Amelia's parts, please do not hesitate to leverage the Q&A functionality. We will also try to get to as many questions as possible during the sessions. Last but not least, the webinar is being recorded, and we'll share the recording and the Q&A with attendees afterwards. You can also reach out to us to book a follow-up meeting to learn more, or subscribe to our weekly newsletter. We'll definitely share details on how to do both those things before we close the session. So thank you again for being here. I'm now delighted to hand you over to the founder and executive chair of SoapBox Labs, Dr. Patricia Scanlon.
Thank you, John. Thanks for the very nice intro for both of us. So I'm going to share my screen and go to present. I hope everybody can be able to see that. So as John said, I've spent my career in the area of speech recognition, machine learning, and AI. But it was actually back in 2013 when I was observing my own daughter, who was not even 4 at the time, working with some really nice platforms and apps and web services around pre-literacy, early emergent reading. And, as fabulous as the pedagogy was, as the user experience was, what I kept remarking when watching her progress or tried to progress was that they were excellent at assessing receptive skills, but what was missing was expressive skills. So as a mother, and I actually at the time knew as much as any other parent about education, but not actually as an expert in the area, observed the fact that, reading simply involves, many elements of education. But one of the real strong ones for me was to watch that the system needs to be able to hear the child, to be able to assess her ability to recall and pronounce the words and the sounds. And this was in the early stages. So my first step when I founded SoapBox Labs was to find out, well, why does this not exist already? And to observe the fact that many people had tried it before. So people had tried to integrate it. The accuracy was never there. It was more of a fad and it faded away. And knowing, as I did from working in Bell Labs and IBM research, that, how big voice technology was becoming. It was pre-voice assistants, but the technology was there, the ability was there. And knowing how big it was going to be for adults and really seeing this gap that needed to be addressed to fulfill the full potential of personalized learning, adaptive learning, for literacy and for language learning, to take from the child the whole way through, from what I was seeing from my own daughter and know what I knew from the industry. And that's how SoapBox Labs was founded. So I'll just move on. Just to highlight, which is really interesting, is that a lot of people, when they hear about voice technology, immediately jump to what they envision as voice assistants. So that's where we all got really familiar. That's where we got widespread adoption. That's where it got normalized in our lives. It was through voice assistants in our kitchens, so through the Alexa, through Google Home, through all these different environments like Siri. But for us, and for me particularly, in my career, voice assistants were always envisioned, but they were envisioned as one use case for speech recognition, not speech recognition in its entirety or voice technology in its entirety. So as useful as they can be in the classroom, some ways, there's some great skills out there that are engaging for kids or for adults, but really to note that voice technology is so much more than that. Voice technology is voice is how we communicate. It's an interface. We can use voice now today to interface with technology like we were never able to before, because the accuracy is there. But more than that, we can harness the power of voice to act like the helpful adult, the helpful teacher, the helpful expert when it comes to our kids and their education. So why do we need speech recognition specifically for children, right? So that's what we do at SoapBox Labs. As John said, we build speech recognition specifically for children. It's proprietary technology that we license to our clients and our partners to integrate into their products and services to get the best possible experience in terms of accuracy and privacy. But adult voice tech is prolific in the area. We all know these systems are out there, but why are they not delivering the experience for children? There's a lot of really good reasons for this. Think about it, children's voices, and when we talk about children, we're talking about kids aged 2 to 12. Their voices are very different, and that's because they're physical differences, right? So their vocal tracts are shorter and thinner. Their vocal cords are smaller. So actually their voices reside in a different part of the spectrum, right? So the frequencies and the pitch of their voice is very different from adults. So if you think about a 4-year-old girl or a 50-year-old man, and you can imagine and to process how different that voice sounds. Humans are very good at adapting to this, but computers need to be able to do all this, and it's a big ask, and they tend to perform less well for kids. When we think about kids' speech, it's their language that is very different. So if you think about how a 2-year-old or a 4-year-old, or 6, 8, 10, their language development is not just age, really. It's more about language development for the child, how they use language structures, how they don't use language structures when they're very young, how they're so unpredictable. I mean, the variance between how kids speak is so different to how adults speak. Their behaviors in terms of how they elongate words, over pronounce words, over punctuate while they're thinking. And all these things, if you think about a system that has been modeled on adult voices, modeling adult language and adult behaviors, and suddenly you get this kid using it who's, all the rules are out. Kids don't do what we do. So as adults, we tend to think about the fact that we're going to use a speech recognition system. We straighten ourselves up. We think about learned behavior, about how we phrased it before and what worked and what didn't work. We formulate our request and we use it. And kids don't do that. Kids are just going to blurt out what they say. They're going to read, but sometimes they're having a bit of fun. Sometimes they're being quite serious and they're stressed. The variance in what they do. And you can imagine how systems built for adults, modeling adult voices, behaviors, and language are not going to work as well for kids. And the problem there is, if you have a mature sounding 10-year-old, they're very adult-like, they've got very adult behavior and adult voice, they're trying to be more mature, it can work reasonably well, but the minute you start going to the younger kids, lower and lower in age, you're going to start to see performance really tanking for systems that have been built for adults. And that's really hurting the child's experience, right? So the environments they're in noisy environments. They're in classrooms and kitchens and TVs in the background and adults speaking and other kids. And systems, all these conditions are really hurting for kids when they try to use these experiences that haven't been built for them, and the performance suffers. And therefore a client who is integrating the speech technology without really taking this into account, it impacts your brand in terms of the accuracy. The privacy concerns, the privacy needs of kids are very different to adults. Adults make their own decisions. It's not as simply as we just going to, hand over the rights to of our children's data. We need to be able to think carefully about the experience and how the data is handled and how the experience is handled for children and what happens. And very much so, that's why we need speech recognition specifically for children and built for children. So the fundamentals we have here are the focus. SoapBox Labs has spent 8 years focusing and building on speech recognition for kids. We have over 130 years expertise in speech recognition technology, so we know what we're doing and we're very good at the voice. We don't get involved in the end user product. We license our technology to the experts and other companies who specialize in this too. We've thousands of hours of kids' voice data from all around the real world. And this is accents. This is accents from across the globe, dialects from across the globe. And that's really important when you're trying to build robust speech recognition for children. Our models, they're state-of-the-art deep learning solutions. These are deep neural networks, you sometimes know them as, and that's state-of-the-art in technology, and that's how you get the high accuracy. On top of that, we have our layers of intellectual property that we have expertise in now after all our years in SERI, knowing how to handle and process children's voices. So ours is a plug-and-play SaaS infrastructure. It's low code, easy integration. Some of our clients have got up and running in less than 48 hours, and that's really important. That was one of our goals as well, to have a global infrastructure that's scalable, that's near real time and easy to work with, and people can get up and running. And we're an independent company. We don't have any competing business models other than speech recognition for children. And that's really important when it comes to our values as well, as why we do this. So one thing I really want to talk about, and I've mentioned a little bit already, but it is so important and sometimes worries me about the industry when we talk about accuracy. Sometimes people pay lip service to accuracy, but what's really important, and again, how it reflects on your brand, is the accuracy. And accuracy in terms of what happens when the child reads a sentence correctly or says something correctly. But what happens if they don't? How does the system handle it when the child isn't behaving as they should? And then what happens with Not just how many words did they get correct, but how many false positives and how many false negatives. So false negative is when you're telling a kid they are, I'm going to get this right now. False negatives when you're telling a kid, as most of you will know that have any interaction with kids, you tell a kid they're wrong when they're right, you're going to have serious confidence issues. The kid will be indignant. They really won't like that experience. If you tell them they're right when they're wrong, that's not educational. It's really important to balance these. Even humans get it wrong. So human accuracy is really important here as well, how we compare to that. But it's really important to balance this. And we don't just brush this under the carpet, as in, it's fine, it kind of works. It's important it works. This is education. So what we've done is worked with our colleagues in our partners in the Florida Center for Reading Research, Dr. Yakov Petra, for over 2 years now, and they've independently validated the system. They've developed, as Yakov says, speech recognition that actually works for kids, because this is not trivial to get this to work for children. But also they've been able to work and validate the accuracy of our verification system in terms of compared to human evaluators, which is really important, human assessors, experts, as well as being able to assess it for bias. So there was no difference between Black and white children, Black and Latina children, Latina and white children, and across dialects. And they did assessment on kids, thousands of children across all dialects in the US. And that was really important for us to work with these guys and get that independent validation that this system works. It isn't bias. It isn't going to contribute to the already unequal system that's out there that we all know about. So just want to touch on play a little bit here. We have SoapBox Educate and SoapBox Play, as Jon mentioned. They're two of our verticals, two of our efforts, but sometimes play might inspire some of you guys to think about even an edutainment, even though we're focusing on educate today, even those edutainment kind of scenarios and experiences where we can learn through play as well. It's not just purely formal assessment and practice. So we have wake word, and we do custom wake words. We do voice activity detection. These are really great for user experience, waking up the system, not having to use button press. We also do things like voice search. We enable dialogue, transcriptions, and voice control. So all of these can be really cool experiences. And Amelia is going to walk through, how our systems work in different scenarios. But you can imagine these working for dialogues, for search, for control, all these things as well. And when it comes to educate, which is kind of the focus of today's talk really today, is about how we enable kids in different ways when they're doing literacy, when they're doing language learning, in terms of our assessments, right? So we do pronunciation assessments. So this is down to the phonetic level. We do fluency assessments. So that's the words correct per minute, errors, substitutions, deletions, all this. Amelia's going to talk more about this again later. Our keyword spottings, when you ask a child, you can give them multiple choice questions, but also you can allow a child to answer naturally. And then we can pick out from whatever audio they say, if they answer in one word, what color was the house? It was blue. The child just says blue. They say, I think the house was blue. Our system can handle all that and scan the audio and pick and give confidence for all those scenarios. So this is really important when you're talking about practice, when you're talking about summative assessment, formative assessment, comprehension, all these different ways of assessing kids. And all of it can happen invisibly for the child. And that's really kind of the goal here, is that what kind of experiences could you imagine you can create for a child to the point where they may not even know they're being assessed regularly, but they may not even realize it. They're just having some engaging content and the system is all the while assessing them in the background. But what was really important when we started this was to be able to assess a child through all stages of the reading journey. So as I said to you, when I started this, it was very much about watching my own daughter when she was in that, pre-literate emerging stage of reading. So it was very important that we were able to do this all the way, that the accuracy of the system was constant through all ages. So when a child is 5, you can have the same system underlying their literacy learning from age 5 all the way up to 10 and 12. And that's really important. That was really a focus for us to be able to do that. You're talking about language development, vocabulary learning, you know, phonemic awareness, right up when you're doing your phonics and letter sounds, your blending, decoding, the child is beginning to read words, whether it's sight words or through phonics, but through sentences, your short phrases, your answers, but right up to fluency and comprehension. So you're really taking a child with the same system, same accuracy for kids the whole way up. And that was really, really pivotal to what we wanted to achieve, what we have achieved in our 8 years. So the areas that we're working in, that we support our clients in, is for screening, for things like dyslexia screening, for instruction, for intervention, for practice, that regular practice, that fun and visible practice. The kid doesn't even know that they're doing it, but they're having these great experiences. And then for formal and summative assessments as well, as I said. So what we're trying to convey here is that voice it's kind of like a new category of data that you guys can actually leverage for your systems and your products to integrate and bring better experiences for children. So for kids, think about how they could be on an iPad or a laptop or a Chromebook or wherever, and they're engaging with the experience and they get real-time feedback. And that's really important for their engagement, for their learning, for their instruction, for their intervention, for their practice. For teachers, what we're doing is be able to feed into dashboards that they're already familiar with, and to be able to support, you know, this elusive thing of personalized learning, adaptive learning for kids is so important for progress in this area. But it's really important to note that it's not been possible in literacy or language learning without voice technology, not fully anyway, we all know that. For school districts, you know, so you can imagine seamless integration of this new data points. These are all just new data points that you guys can use to be able to integrate with digital reading records and to be able to actually to perform longitudinal analysis of schools, of districts, of classes, and knowing how they're doing. And for EdTech companies, imagine being able to bring out products and very quickly, not just through simple, you know, focus groups, whatever, but in real time to be able to update features, change, tweak, tune, but getting real-time insights into the efficacy of the products you're producing and the features you're producing and your updates and your changes. And we really feel that this idea that voice gives you a new category of data can be useful in so many different ways for the child's experience. So I'm going to pass off to Amelia here. If you have questions, please put them into the Q&A and we'll try and address them at the end, or it's the last 15 minutes anyway. But Amelia, I'll hand over to you for the demos.
Thank you, Trish. And thanks, John, for the introduction earlier as well. Hi, everyone. I'm Amelia, and I'm delighted to share a demo of our technology today.
So I will stop sharing in case that helps.
Oh, yeah. Thank you. So actually, I think I will start with, so I'll just get this down. I will start with verification. Okay, so what I'm going to show you today is the simplest version of our technology, what we started off building and what we kind of felt that was really needed for educational applications of speech technology. Usually when I'm describing the difference between adult speech technology and child speech technology, I mention the differences in the applications. Everybody's aware that they, you know, talk to Siri and they get responses, but also adult speech recognition has been used a lot for, by example, lawyers who are dictating, and they'll read what they want written, and the speech technology will write it down word for word, and that's the application of speech technology for adults. But for children, it's a lot different, and especially young children. So that's why we created this verification technology. Usually when you're using speech recognition for children, you, for example, already know what you want to test. For example, you want to test if a child is reading a sentence correctly. And this is why we set up this verification system. So in this system, as the user, you would send to our system an audio file of the child's reading a sentence, for example, but also the sentence that you wanted the child to read. So let me give you an example.
The horse ran fast.
Here's an example of a child saying the horse run fast. when they were actually supposed to read the line, "The horse runs fast." Our technology would take in this text file and this audio file and return a score. In this scenario, the target is the sentence that the child was supposed to read, "The horse runs fast." And here we returned a score of 82% for this target. This indicates how well that the child pronounced the whole sentence. But we also go a bit more granular than this.
The horse ran fast.
Again, you can hear that the child said the horse run fast and not the horse runs fast. So what we've done is we've broken down the results word by word and given a score for each word in the sentence. You can see the score for the word runs is quite low. And again, we break it down even further. So we can go through all the individual phonemes and we find here that the Z phoneme only scored 6%. That's akin to saying that it didn't actually happen in the sentence, and we can hear run is not runs, and we've correctly identified that the Z sound was not spoken by the child. Again, our technology not only returns these percentages on the utterance, word and phoneme level, but it also returns the start and end times for each individual speech unit, which allows the teacher or educator or the user to listen back to the different parts of the sentence.
Fast.
So phoneme by phoneme, we can listen back to what was said and compare it to the scores. Again, Trish talked about the false positives and false negatives. It's very important that we give a high score when the child actually said something that they were supposed to say, and a low score when they didn't, like in the case when they were supposed to say Z at the end of runs and they didn't. So that came back as a low score. This is a really good example of how our system can discriminate between what was correctly said by the child and what wasn't said. And it gets this really high accuracy that Trish mentioned, with minimum amount of false positives and a minimum amount of false negatives. Another good application of this verification, and a great feature of it, is that you can actually look for different targets. So here, actually from a previous run, the target black and white remained in the system. So let's look.
Horse run.
So we got the in run corresponding to the and, but otherwise everything scored really, really low because that's not what the child said. That's a good example of us correctly detecting that the child did not say anything in this target. Let me show you a further example and talk about some use cases of this. So we frequently get asked, what about a situation you don't want to just check whether the child read a sentence and look at the results that come back, even on those words and phoneme level. We, for example, want to see how well a child understood something that they read. So for example, you could give a child a passage about a dog, and you could then check to see whether they understood what they were reading by asking questions about the dog that the child can then answer freely. This can be tricky because the child can say anything. However, you do know what the correct answer is in advance. In this scenario, the dog has black spots. So what we can do is check to see whether the dog is black and white, for example. Whether the dog is white with black spots, whether the dog just has black spots, or if the dog is, let's say, red and blue. We can check all of these simultaneously in one call to the API. So we play the file that the child actually says. This is what the child answers when they're asked about the dog.
The dog has black spots.
So what do we see in our results? We get all these targets back simultaneously. And we can see that the highest scoring target is the dog has black spots, which is exactly what the child said.
The dog has black spots.
We can also look at some of the other high scoring ones. The phrase black spots, for example, comes back scoring high.
Black spots.
It's because the child actually said that within the audio file. Now here's a really good example of keyword spotting or key phrase spotting. So imagine a scenario where the child said, I like dogs. Dogs are really cool. I really like the dog in this story. That dog was, it wasn't a red and blue dog. It had black spots. We'd still be able to find the phrase black spots in it and ignore everything else that the child said that wasn't actually pertinent to the question. We can see black came back scoring high, but white and came back scoring low.
Has
and
black
again,
spots.
white or black spots again comes back scoring high, and white and comes back quite low. I think there was another one we did, red and blue.
Black.
See, the bl from black matched up with the bl from blue. But other than that, actually that's a really good one, because we correctly detected that neither red nor and were said, and the word blue wasn't said. Even though most of it actually occurred in the word black, we were correctly able to identify that enough of the words were different so that it wasn't the word blue. So we've correctly given it a very, very low score here. So that's all I have for verification. I'm very happy to answer any questions you may have in the Q&A session at the end. So feel free to use the Q&A to ask your questions here. Sorry. And I will move quickly over to the fluency product that we have. So the SoapBox engine can do many things. The verification aspect of it is one thing that it can do. If you can imagine the SoapBox engine as this entity in the middle, and you can use different features of it. If you want to use verification, it's very easy to do. It's off the shelf. You can send the audio file and any word or phrase or a collection of words or phrases to compare against the audio file, and that works out of the box. We have a more sophisticated feature of our voice engine that works with longer passages up to and recordings up to 1 minute in length, where the child is reading a passage, and traditionally a teacher would sit down with the child and mark off on a piece of paper whether the child said each word they were supposed to say correctly, whether there were any inserted words or extra words that the child said, whether they left out any words, omitted or deleted words, or whether they substituted some words for different words, be they words that sound like that word, or maybe they're words that are semantically similar. So I've put in some examples here. What I'm going to show you here is this reference passage. So this is the passage that the child was supposed to read. And it says, "Aha," shouted Audrey Croft, "the circus was a sham." I'm just going to change this word here, homes, to houses, to show you what I mean. So these are the types of differences that children say sometimes when they're reading. And I am going to play a passage of a child reading it now.
"Aha," shouted Audrey Tuft, "the circus was a sham. Make a trick to people, leave their homes. You're not circus people at all. You're just crooks." "Crumbs," shouted the thieving snails, "we've been discovered. Run!" I knew we should have pretended to be dentists instead," grumbled a snail. They turned, as slow as honey dripping, as slow as drizzly Sundays, as slow as, well, snails, they sought to escape.
So this is a lovely example, not only because the story is quite funny, but also the child is obviously a very good reader and reads with great expression. And also there are a few just little errors that anyone, even adults, would make while reading this. First of all, the child did a sound-alike substitution error. So they were supposed to say Audrey Croft, and instead they said Audrey Tuft. And you can see here, this is marked in blue as a substitution. As we go along, the child said, "The circus was a sham, make a trick to people, leave their houses." And you can see here that they were supposed to say a trick to make people leave their houses. So you can see here we have an insertion word, make. And we can see that we can get the start and the end time of that, so we can listen back to it. Also, the make they were supposed to say later on becomes a deletion or an omitted word. Again, the substituted word I put in here. So I pretended they were supposed to read houses instead of homes, and instead they said homes. So this simulates a semantic error.
Homes.
We can see that they were supposed to say houses, instead it came back homes. So not only do we give the word that the child was supposed to say, but also the word they said instead. Again, we give the confidence score for how well they said the transcription and the start and end time, so you can listen back. Again, here are some insertions. The child said, "I knew we should have," I knew we should have, and you can see here all those extra words are highlighted in yellow as insertions. And later on, they were supposed to read the word and they actually omitted it. So this is really useful. What we have here is essentially what the teacher's page would look like after they listen to the child reading and they mark this all down. And we've talked to many teachers about this, and we actually have a backlog of other things that we could add in that would actually occur to the teacher as they listen to a child reading. For example, if the child repeated a word, it may not necessarily mean they were making an insertion error. It could actually mean that they were just convincing themselves they'd said it properly. So this is something that we're coding into our system at the moment, and I think is actually available in version 1 at the moment. As well as these individual pieces of data associated with the reference passage, we collate the data as well. So we can show you that in this passage, there were 7 insertion errors, 2 deletions, 2 substitutions, and there were 67 correct words out of 71. We can also show you the duration of the audio file, which is over 36 seconds. And using all these data points, the user then can calculate metrics by which to grade the child or indicate their reading fluency level. So we have here accuracy and words correct per minute. Now, words correct per minute is most commonly used one in fluency, but we supply all the different metrics and all the different data points required for you to calculate your own metric or any of these metrics that are normally used in fluency evaluation. So that's all I have for the moment on the SoapBox engine, but I'd be delighted to answer any questions that she might have. So I'm going to hand back to Jon now, and thank you for listening.
Perfect. Thank you both. I think we got a lot of questions. A few came in before the webinar, so I'm just going to start which you addressed a little bit at the top. I think both of you addressed this question, but I think it's important to reiterate. Does your voice tech cater to different accents and dialects kids may have? Amelia, I'm going to give you that one.
Great, I love this one. Yeah, we're really proud of the way our system handles accents and dialects. From the get-go, we made sure that we were building a system that works in the real world. Both Patricia and I have extensive experience in building speech recognition systems, and what we're both aware of and what everyone else I think is aware of at this stage as well is that if you build on recordings from children in very, very clean environments with just one accent, then you create technology that only works in very, very clean environments for children of that accent. And that is bad for education. What we want is a system that works for children in the environments where they frequently find themselves, for example, classrooms, cars, kitchens, homes. And also, we want to create technology that is equitable, that is works equally well for different demographics, children from different backgrounds, children with different accents and different dialects. So we have built our technology on an extensive database that is growing, and we have children's voices from 193 different countries in all different types of environments, using all different types of devices, and in situations where they are acting the way that they will act with technology. There's nothing artificial about our database. It's purely built on real world stuff. And also, in addition to that, and the reason that our technology works really well now is that we are also using the state of the art in neural network technology. We use deep neural nets, and combined with the processing power that's now available to us and the data we have, we can actually model these accents and dialects super well in a way that's never actually been seen before. So because of all these things, we are able to get very accurate results regardless of the accent or dialect of the child.
Yeah, and I'd even add to that going, if you went back a decade ago, you would have been building models for a Northwestern accent, a Southern accent, and that was the limitation of the technology a decade ago. So we know we've moved on, the world's moved on, and deep learning is the future. And that's how we're seeing any progress in AI at all. It's just being able to process that and process it intelligently and in a very balanced way. But it's very important that attention is paid in a company's own internal evaluations and getting it independently validated, because you can't let bias creep in. You can't have it working less well for one cohort of the population or one demographic than for another. And that's been a focus for us, and you know, we continue to evolve the system and improve it, but while trying to pay attention all the while to the impact that might have. And you know, we're evolving the system, we're trying to keep track that this is a global issue, and you just want to ensure the system you integrate when you're looking at voice technology, and test it and evaluate it yourselves, you know, that pays attention to that, and we're not seeing that in the system now, and that's important to maintain.
Awesome. Thank you all. We got a lot of questions, so I'm going to bounce around a little bit. Trish, this question is for you. Kind of in the beginning, you talked a little bit about performance. And it says, can we clarify what is meant by performance? Are we specifically talking about the ability to map the audio input to text?
So it depends on the product, what we're talking about. When we talk about speech recognition technology, generally it's phrased in terms of word error rate. That's kind of a very commonly used term for the last couple of decades in speech recognition. And what that does is map audio to actual typed transcription to be able to validate it. When we're talking about our verification, as Amelia would say, is that we're looking at our false positives and our false negatives and the statistical analysis of that as well. So it does depend on whether you're talking about confidence, because that's on a scale. You know, biometric systems work like that as well, that, you know, you've confidence whether it is a person or it's not binary. There has to be kind of a threshold in there. So we are always ensuring that it's either word error rate or it's confidence of the accuracy. Would that be correct, Amelia? Do you want to add in any more color on that?
No, I think that's perfect. I suppose when it comes to performance, there's false positives and false negatives, but there's all these different data points that we return that go beyond just a transcription of the file. So for example, the start and end time, the normalized text, the confidence scores, all these are really, really valuable data points. And when we talk about performance, also, you know, we're taking into account latency as well. So like our verification product works really quickly off the shelf. And sorry, just to actually another question I see here that I was beginning to answer, but I think it fits very well into this as well, is George Sturpu, hello, asks if it would be possible to assess a child's pronunciation without the target text. So in the verification example I showed you, you put up the target text and the audio file. And we also have a speech to text endpoint where, again, we return the transcription of the text. Now, performance can be measured by how well that text transcription matches the audio file. But yes, we do also return the child's pronunciation right down to the phoneme level on the speech to text thing. So it's just all these metrics together, all these things put together are what we are talking about when we say performance. And it's
good points. Well, no, that's perfect. I mean, and the idea is rigorous evaluation across ages, all ages. So to be able to say that we perform well for all ages has been really important, because kids start their learning journey early. They don't start it when they're 8 or 10. They start it early. So if you want to carry a child throughout their learning journey, you need to be able to have the performance. So there's a lot of different factors in what we evaluate when we say performance. So.
And actually, just on that, it's in our internal testing that we do quite rigorous testing all the time. And, you know, one of the things we look at are the different age groups. And one thing that, you know, it's really nice to see every single time we run the test is how well the 4-year-old voices compare to the 8 and 12-year-old voices. It's all across the board. It performs equally well. And we test against other systems as well. And we can see that anything built for adult speech just does not work for 4-year-olds. It just doesn't. It takes so much more effort and such different types of data and modeling and everything to make it work for kids very young as well as the older kids. So,
yeah, very much so.
Perfect. This ties into it a bit. And I think you're both going to have an answer to this. But considering this technology primarily is working on with children, how do you ensure safeguarding the children by this technology?
So a lot of this, you know, going back to the very beginning, you know, I was a speech recognition AI researcher, but I was also a parent, you know, so knowing that, you know, and this was prior to all the privacy concerns and stuff, what we did was design a system that would safeguard, had privacy built in from the beginning. So it wasn't quicker or cheaper to do it this way, but we kind of felt like we needed to be able to stand over everything we do, and we need to be able to safeguard and respect the digital privacy rights of children, and to be able to the point where any data in our system is in full compliance, collected with GDPR, COPPA. We delete data where necessary. We delete data on request. We actually have no way of connecting a piece of audio to a child or an identity of a child, and that's been really important, unless in the case where we're supposed to, because we need to be able to delete on request. So safeguarding, it's very much about the security and encryption of data as it's uploaded, as it's stored, secured, as it's built. And all the while there's a framework there, and it has been since 2013. And we work with Prevo, which is a safe harbor in the US that's been around for about a decade now. I think it's about 20, maybe even before, actually before, they're around quite a while. To be able to audit the system and be able to ensure that we always, work with council on this as well, to make sure that we have a system that has been built and delivered, and keep track of all the safeguarding requirements, and that's globally, right? So that's changing all the time. You got to keep abreast of it, and got to make sure we're doing what we need to do, and we're doing more than that as well, to be able to, protect those rights.
Perfect. Amelia, anything to add? That was a pretty comprehensive.
That was pretty comprehensive. Patricia's the queen of privacy, I think.
Yeah, we have a few people on this. Yeah.
Yeah.
I like this question, actually. What does the panel see as any obstacles to adoption of this new technology?
A lot of this is, do you know what one of the big ones is people's preconceived notions that it does not work for under age 8. And I've heard that so many times in the past 8 years. And one is that you can't possibly get it to work for a 4-year-old. Just think how a 4-year-old works. And we're constantly educating and trying to talk to people who kind of in theory know that it does, but they've got these embed beliefs that it's not going to work accurately. And to those people, we just invite, please try it. Please try it with children. Please try it in the real world, and see. And also the second one I'd see as well is that people, as I said in the beginning, they convolve the idea of a voice assistant with voice technology, and they think that's what it is, and that's the limitations. And this does hold back the industry because of this. It holds it back because people think it can only be so useful, and that kind of limits the potential. So we're always trying to inspire people, about what they can do with voice technology, how it can improve your system, how they can make it more engaging. So trying to undo those long held beliefs that it won't work for kids is definitely one of them.
Sorry, I got lost in my questions. I'm going to go one more kind of general, and then we'll kind of get in a little bit specific into the demos. But how does a noisy environment affect the accuracy of your technology?
I think Amelia touched on this already. I'll answer it, and then I'll kick over to you. A lot of this was, in the very beginning, I had been working on speech, state-of-the-art speech recognition for adults. I had a 4-year-old. What I noticed was anything that was out there for kids at the time, this is 2013, used to say works in a quiet noise environment. If you're having problems, your environment's too noisy. If you're having problems, you need to use an expensive headset mic. And I was looking at my 4-year-old going, she never is in a quiet environment. She is at my feet. She's with her siblings. She's in, her preschool. She's, for us, there was no point building this technology. There was no point starting this effort if we couldn't deliver technology for kids, young kids, and in real world noise environments. So as Amelia said, we collected this data, and it was very important that we kind of supported this effort. That what is a real world environment for a child? Like, how do you work with that? How do you ensure that the system is built on real world data, not on a clean data set that a university group collected 15 years ago? And there's some great ones out there, but they're not representative of the real world. And I think, really, you touched on this as well. If you build technology off a clean data set, the children were controlled, that the children were in a quiet environment, that, and probably on a USB headset mic, you know, yes, it will work if you replicate those exact conditions. But for a contemporary state-of-the-art system for 2021 or whatever, it was back 2013 all the way through, it has to work in the real world, you know, because we're not going back a decade to where it's quiet. We're not asking kids to sit quietly at a desk in their room, because I mean, what 4, 5, 6, 7, 8-year-old will do that? You know, and it needs to work in classrooms, and it needed to work during the pandemic. It needed to work in homes, and that continuity between classrooms and the home. And that's what our technology does, because that's what we started out doing. That was the ambition from the very beginning, to make sure this was a contemporary state-of-the-art solution.
Perfect. So now around the demo, Amelia, specifically this question goes to verification. Are you able to do semantic matching at all? So for the dog with black spots example, if the child said spots that are black, how will that match versus black spots?
So in that particular example, you have spots appearing before black. Basically what verification is a very, very simplified version of natural language processing. So while we don't do any kind of semantic matching on our end, it's kind of inherent in that you are looking for different versions of the dog as black spots. So if you come to this version where the spots are black, what will happen acoustically with the alignment is the spots part will probably line up. If you want to see black and spots simultaneously and you don't care what order they appear in, you can put them as individual words, black as one target, spots as the other target, and it will simultaneously look for them within the sentence, but you'll get no information back about the word order. If you want, the dog has black spots. If you want to put black spots or spots are black, you can look at those as individual targets. So essentially design comes into it quite a bit. If you are creating a platform where you're asking a child these open-ended questions, what you're going to have to do is think about the possible answers that you would accept and that you would build out results for. The interesting thing is that even if we returned just a straightforward transcription of what the child said, the person making the platform that the child was using would still have to decide what they were going to do once they had the transcription of the file. So if we just return to you exactly what the child said, for example, oh, I see a dog and I heard a story about a dog and I read it and it was great, and the dog, the spots on the dog were black, you'd still have to parse that sentence somehow. And you'd still have to know in advance what you were going to hone in on and answer the child with. So you'd have a set of rules, for example, like if the dog, or if the child said the dog has black spots, or if they mention the word black or spots in any order, then we will say this particular thing like, yes, you are correct, the dog does have black spots, this is what the dog looks like. And if they don't say any of that, you have another canned response like, actually, could you read it again? Because I think you missed what color the dog was. So the interesting thing about verification is that we take that parsing load off the client completely, and we do it automatically in the one call to the API. So you decide in advance that the black spots are important, or black and white is important, or various other things are acceptable answers. And then we will return to you whether they said those, and already you'll have to build out the response to the child anyway. So it's kind of just a quick way of doing that kind of NLP.
Awesome. I keep saying awesome because there's so again, kind of diving a little bit deeper into the demos. How old were the children in the examples you played? Horse runs fast, black spots, etc. They seemed extremely cooperative. In other words, what if a child says the target correctly, but does so sloppily, quickly, or muffled?
We do actually have some examples of that. We had an example on the demo that I didn't show where the child was asked to say something that was slightly beyond their reading abilities. The sentence was, this is an arachnid, and the child in question was, I think, age 5 or 6. So the vocabulary was out of their range, and they stumbled over the pronunciation. They did a very good job of it, in my opinion, but it sounded like more like this is arachid or something like that. And you can see in the phoneme breakdown of what we show that we return high scores for the phonemes that they did say and low scores for the one they didn't say. So it's not like this only works when children are totally well behaved. That's not true at all. in fact,
when they're mumbling.
Yeah.
Yeah. So I suppose a good way of looking at it, Amelia, wouldn't it be if as much as we're able to identify a substitution, a mumble or something like that would be the same thing. You'd get a low score for that particular phone number. Yeah.
Exactly. So if they're saying instead of or, you know, or they're saying instead of or it's coming across that way, then we'll just get a low score on that particular phoneme. And just to answer your other question, the children who were reading quite well, I think they were 7. So yeah, and again, our technology, actually I have a 2-year-old daughter, and even before she turned 2, the technology was correctly able to identify her saying the few words she had at that point. So yeah.
Yeah, we have kids out in Asia using it from 2 up as well, like, you know, with one of our clients. Yeah.
I think that there's kind of a deeper second part to this question. How does SoapBox deal with children who have speech impediments? So it's kind of taking that other question and going a little bit deeper to a specific example.
Sure. So I think, Trish, you mentioned this, you said this quite succinctly when you say that we leave it up to the educators to decide how they're going to use our technology and the best use case for it. So in the case where a child has a systematic speech impediment, or they pronounce some phoneme in a way that is identified as something that they might want to correct, or something that is unusual for their particular age of development, then what will happen is, just like any mispronunciation of a phoneme or a word, a low score would be returned by our verification engine. If the developer of a platform that was addressing this issue, and in fact, we do have some clients that are trying to assess children's pronunciation of individual phonemes at different ages to see if there's any systematic trends. If they see a systematic low score across one phoneme, then they can infer that the child is having difficulties pronouncing this. Then they can use that data to maybe, you know, try and intervene and get the child to practice and do exercises in that area. So again, what we do is the same across the board. We're returning the pronunciation score of how well a child pronounced something, and then the data points are surfaced to the user, the developer of the speech platform, be it for education, literacy, or any kind of intermediary or intervention steps like that. And they can use that information in whatever way they want. So yeah, we try and remain agnostic, I suppose.
Perfect. I'm going to ask, we're running close to time, so I'm going to ask 3 more questions, and then again, we'll have a follow-up with a recording, and then
it's going to be rapid fire, John. 3 questions, 3 minutes,
rapid
go.
Fire. Are you pursuing automatic scoring of prosody? That's fast.
Yes. Yes, we are. It is underway and it's very exciting. So there's lots of information that, you know, and the differences between child speech recognition and adult speech recognition is the stuff that you actually want to know when the child speaks. You don't necessarily just want the transcription, but you want to know whether they paused in the right places after the punctuation, whether they did the right intonation up and down, whether they raised their intonation at the end of a question. All these different things are all very important, and they are indicators of how fluently a child reads. The stress info on different parts of the words, the pitch info all across the sentence. So what we're doing at the moment is that we're looking at the best way to convey this information back to the user in a way that would be most useful to them to infer the child's reading ability using these metrics. So that's all underway and it's all very exciting.
Okay. So second to last question. What is our vision for how this technology can be used in consumer-facing play-based products, toys or entertainment, as mentioned earlier, in an ethical way?
Yeah, so this is a big focus of us going forward, you know, an ambition that a lot of, whether it's a digital toy on an iPad or an iPhone, or, you know, we can use it online or offline. But one of the ambitions as well is to be able to take this technology, it's the same technology, right? So whether it resides in the cloud, same accuracy, to be achieved in an offline solution as well. So that's kind of fun. So you want to be able to, a lot of education, it needs to be online anyway because of teacher dashboards, homework, feedback to teachers. Teachers want to be able to listen back to it. It's got very different use cases. But when it comes to play, sometimes a kid's handed an old phone or an old iPhone. We want to be able, they don't have, they're 5G, they don't have a SIM card, but they're sitting in the back of the car and they want to be able to play. Or they just don't have internet for whatever reason. We want to be able to do that. We have an offline version that's as accurate as the online version. And we're also working very actively with a number of partners on getting onto low-cost chips that are ultra-low power, but same processing capabilities, deep neural nets on chip as well, to be able to do voice experience through play. Hello, how are you? Have a little conversation, do voice search, control a robot. There's loads of cool things to be able to do when you put it on a chip. There's no connectivity, no Bluetooth, no nothing needed. Just, open the box and play. That's the idea.
And thank you. And the last question, which I think is important. How does SoapBox typically work with EdTech companies and help them launch a product?
Is that not your question, John?
Oh.
Can we kick it back to John?
Yeah.
No, not today.
So you know what, like what we've always done is long-term partnerships is where it's at for us. Like, we want to work and personalize for our clients in whatever way. And we work with them. We have some partnerships that we do long-term with people as well. It's be able to work with them about their needs and listen to them actually. And sometimes, the prosody thing that Amelia's talking about, all these things have sometimes been through a couple of clients looking for something, and then we work with them in the long term. But when somebody wants to work with us, if you've developed a product, you can pretty get, once you've talked to John or some of our business development people and get access very quickly to technology, you can get up and running with our API key and integrate very quickly. So it's kind of a case of whatever your product is, if you have some more bespoke needs or you're looking at a long-term partnership, that's where we love to talk as well. We also have SoapBox Studio, which helps people who want to get involved in voice, but want a little bit more thought and experience and chats about how do I integrate voice in the best way? What's the best experience? What do we know? Because we have 8 years experience with this. We've seen a lot of different use cases across a lot of verticals, a lot of different companies. And we help our companies as well, our clients and our partners help identify what's the best voice experience I can create for the kids.
That's perfect. Exactly.
Do you not answer that even?
No, I think what you said.
You can give the next webinar, John.
I think what you said is really important. Long-term partnerships. We have people, specifically clients and prospects at various stages of understanding of how to leverage voice and enable their products. And a lot of times what we do is if a company has multiple products, it's looking at things like an audit to understand where does voice fit in. And again, I think the long-term relationship becomes very important because you're not just buying a piece of software, you're enabling your own products.
And sometimes it's taking that kid right through that whole journey. Like, there's a lot we can do together.
Exactly. Well, thank you all very much. Thank you for all the folks that attended. If you do want to learn more, have a conversation, follow up, deep dive, you can reach out at hello@soapboxlabs.com. Again, hello@soapboxlabs.com. Thank you all for joining us, and I hope you all have a magical Tuesday afternoon.
Thanks, guys. Thanks,
Bye.
John.
Thanks, everyone. Thanks, John.